Okay, good morning. So, today we're dealing with Pythagorean theorem, and we're saying that the Pythagorean theorem only affects right angle triangles, right? Now that's a triangle, or any triangle that has a right angle within it, right? Now, if you want to think about a right angle, think about two perpendicular lines. For example, if you look at the wall in comparison to the ground, right? That's a perpendicular line. So if you think about perpendicular lines, think about a L, right? Right there's your right angle. Now we're saying that some Greek mathematician named Pythagoras came up with this idea that to find the longest side of the triangle, right? Let's label it C, or it's otherwise known as the hypotenuse. So weird spelling word. Right? There it is. In order to find the hypotenuse, right, we can square both sides, otherwise known as legs. So here's leg 1, leg 2, right? Now for the sake of this lesson, we're going to call this leg A, this leg B, and the hypotenuse we're going to call C. So our theory says that C squared, or the square of the hypotenuse, is equal to A squared, or the square of one leg, plus the square of another leg. Right? Everybody got that so far? So this is what you want to write down right now. This is the main theory. C squared is equal to A squared plus B squared. So, moving on. Simply put, if we have, for example, a triangle with legs of 2 and 4 centimeters each, then we can find our hypotenuse, right? Our hypotenuse. So in this case, remember in our formula, C squared is equal to A squared plus B squared. Then C squared would be equal to 2 squared, right? Here is A, remember, this side is A, this leg is B. So it's 2 squared plus 4 squared, right? Which gives us 2 squared is what? Exactly, 4. Plus 4 squared, which is what? And don't say 8. 16, right? So then we add it. 16 plus 4? 20. Good. Now, so we're saying C squared is equal to 20. However, we do not want to find C squared. We want to find what? C. Everybody remember that? Good. Now remembering back to irrational numbers and square roots. If we want to get rid of a square, what do? We do the opposite, which is what? There you go. Got it right. We do the square root. So in essence, the square root cancels this. And so C is equal to the square root of 20. Right? Everybody understand so far? Now for the sake of time, I won't simplify the square root of 20. But obviously, punch it in the calculator, you get it. Because the square root of 20 is not rational, right? It's irrational. So you're going to get a decimal. It's not a perfect square. So moving on, right? So let's say, for example, we want to validate our theory. How would we do that? Okay, let's check it. If we have a triangle, I know it doesn't look like a right angle, but that's the whole point. We're going to validate if it does have a right angle or not. So if we have a triangle with the dimensions or the measurements of this, how do we validate that it's a right angle triangle? Now our theory says, right? Remember in our theory, it says that c squared, or the square of our hypotenuse, should be equal to the square of both legs, right? Or the addition of the square of both legs. So let's check that. Let's work that out. Now remember, the hypotenuse is the longest side of the triangle. In this case, which one is the longest side of the triangle? Can't be 10. Definitely can't be 24. So it's 26. Good. It's the longest side. So we're saying that obviously a squared has to be one of the legs and b squared has to be another leg. So the 10 and the 24 have to be legs because the 26 is the hypotenuse. So 10 squared plus 24 squared. Now that's 100 plus 576, which gives us 676, right? Now that is the half of the theory. So a squared plus b squared is equal to 676. Again, a squared is 10 squared, b squared 24 squared, 100 plus 576, which gives us 676. Now our theory says that a squared plus b squared, that answer that we get, which is a 676, should be equal to the square of our hypotenuse. So let's check the square of our hypotenuse. In this case, c is 26, right? So the square of our hypotenuse, or the square of c, is equal to 26 squared, which is, there you go, 676. So both of them are equal. So therefore, our triangle indeed is a right angle triangle. Look it over. Okay, so now having gone over the Pythagorean theorem, let's move it a little further. So let's say, for example, we have a rectangle. Right? If we need to find the diagonal in the rectangle, and we have two sides, or rather the measurements of two sides, right? So one is 15 centimeters, another is 5, right? Now, does anybody see what I see right now? Think about it. Let me give you a second. Okay, let's look. The diagonal in a right angle forms two right angle triangles. Good job. Here's one. Here's two. We have our two right angle triangles, right? And obviously, if we have a right angle triangle, we have one leg, leg A, another leg, leg B, and obviously our diagonal would be the hypotenuse. Everybody see it? Let me see if I can make it a little better. So that should make it a little better. There's our right angle. Now, one thing we always have to remember, the hypotenuse is the longest side, right? I'm sorry, a couple of things we have to remember. The hypotenuse is the longest side in a triangle. Yes. It is opposite the 90 degree. Look at that. Always opposite the 90 degree. And lastly is the Pythagorean theorem, that the square of the hypotenuse is equal to the square of a leg plus the square of another leg. Good. So, that being said, if we wanted to find the diagonal of our rectangle, then we could apply Pythagorean theorem, again, which states c squared is equal to a squared plus b squared. In this case, a squared would be 5 squared, b squared would be 15 squared, right? 5 times 5, 25. 15 times 15, 225. I'm sorry, 225. And if we add both of those, we get 250. Alright? So again, c squared is equal to 250. Therefore, c would be equal to the square root of 250. Obviously, punch that in your calculators. Boom, bam, bim. You got it. Right? So really quick, we're going to go ahead and you're going to take a look at the first question in your source book, right? And that should be the one about the lake. Go ahead, look it over. Again, you know, when you split a rectangle in two using the diagonal, remember, you get two right-angled triangles, right? It makes a world of difference. So you have to be able to use those concepts together. Go ahead, review the lesson. Do try these, and then your substitute teacher will give you more work. Also, I'm going to post up a link from maybe Khan Academy or something, you know, for those who don't really understand it and need more help. You can review those lessons, but obviously from my examples you should understand it. Deuces, see y'all later. Have fun with math. Math is easy. Always one love, peace, prosperity, all of that.